The previous video provided an overview of the process of conducting economic assessments of climate change impacts and evaluating adaptation investments. To summarize, the steps involved in the economic assessment activity are: first, determining the aggregate costs over time from current climate conditions. Second, determining additional costs expected from population growth and socioeconomic development. Third, determining additional costs from future climate change conditions. Fourth, identifying adaptation and risk reduction actions. Fifth, evaluating those adaptation and risk reduction actions on the basis of cost-benefit techniques, that is, value for money, and multi-criteria assessment techniques, that is, consistency with social and environmental objectives. And finally, mainstreaming the findings into policies and planning. This video will go into greater detail about each of the steps in the process, using the example of assessing the potential of rainwater harvesting as an alternative to existing water supply sources for hotels in the project site. This assessment is moderately complex with respect to data requirements and modeling. Conducting an assessment of the potential for rooftop rainwater harvesting will involve data collection and analysis. Generally, there are 6 outcomes that will be achieved through this process. The first outcome will be to determine the aggregated costs over time from water use in hotels under current climate conditions. What we are seeking to calculate here is the total costs for all of the current hotels in the project site, and we're going to use the cost of water as it exists at the time of the study. The second outcome of the assessment will be to produce a forecast or projection of how water use is likely to grow into the future as a result of both growth in the tourism sector, as well as growth in other water uses, such as residential consumption, industry, and agriculture. This will give us an idea of whether the existing water supply will be great enough to meet the expected growth in demand. We can also use these growth estimates to calculate how much the total cost of water will increase for hotels in the study site over the forecast period. The third outcome of the assessment will be a projection of the change in precipitation and temperature over time as a result of climate change. This will help us to identify whether we can expect more or less water to end up in existing lakes, rivers, and reservoirs. The fourth outcome of the assessment will be to use climate change projections, water tank models, and construction cost estimates to determine how much it would cost to obtain water from rooftop rainwater harvesting and how much supply could be expected under both current and future climate conditions. The fifth outcome of the assessment will be to compare the costs of installing rooftop rainwater harvesting with the amount of money that would be saved over time as a result of the avoided costs of purchasing water. This will enable us to calculate how quickly the savings in water costs could pay off the costs of installing the rooftop rainwater harvesting. The assessment would also determine the optimal water tank and rooftop sizes and their expected reliability in delivering water. The final outcome of the assessment will be to investigate other potential adaptation measures to see how they would help to reduce the pressure on freshwater resources in the project site, both through alternative supply and through reduced demand. This might include, for instance, small-scale desalination plants, bore wells, or installing improved water-efficient appliances such as low water use toilets, shower heads, and washing machines. Let's look at each step in more detail. First, we need to identify the study area. For this example, we'll use the island of Nosy Be on Madagascar, a popular tourist destination. The next step will be to collect data. Specifically, we will need to create an inventory of hotels in the project site and collect information about their locations, characteristics, and water use patterns. Different hotels will have different characteristics, including their size, the number of rooms, their proximity to the ocean, their rooftop construction material, the number of stories, and so on. By collecting information on the number of rooms in each hotel, the daily water use in liters, and the cost per liter of water from the existing supply, we can calculate the overall costs of water supply to hotels in the project site under current climate conditions. As we're collecting data, it will also be important to find out which months the hotels have the most guests so that we can track seasonal changes in water demand and compare that to the potential supply of water from rooftop rainwater harvesting. A spreadsheet has been created to assist in the data collection process. The information will be collected through the use of surveys or interviews, most likely with hotel managers. The hotel manager should be informed about the objectives of the study and the benefits that they will get by having more information about water supply costs, current climate conditions, and possible future water supply options they could invest in. Working with the local tourism authority and the local hotel association would be beneficial. A detailed description of the method of how to identify the hotels, contact the hotel managers, enter information into the spreadsheet, and interpret the results will be provided in a separate video. After collecting and interpreting the data about hotel water usage and costs under current conditions, it will also be important to determine how water demand will increase over time and whether the existing water supply sources will be able to provide sufficient volumes of water. Because water users in the project area include not only hotels, but also houses and shops and industry and agriculture, we will need to come up with the best estimate we can about the future growth in water demand from these users. A detailed description of the method of how to identify current water users and to project future growth and demand will be again provided in a separate video. Once we know about current and future water demand patterns, we can look at how changes in precipitation and temperature will occur with climate change over time, and how existing water sources will be affected in the project location. The University of the Sunshine Coast will assist with this climate modeling component. Of particular concern would be a situation where water demand is growing in the area, and yet precipitation is likely to decrease under climate change. Anticipating such a situation will assist the hotel industry and local government to take action and make investments to slow water demand and increase water supply to avoid severe water shortages in the future. It will be very useful to determine which actions and investments are the best value for money and are consistent with tourist expectations and sustainable development criteria. The University of the Sunshine Coast will provide information about the performance and reliability of different roof size and tank combinations so that local hotel owners can determine if the costs of installation would be recovered over time by savings in water purchases, or perhaps if other actions are more appropriate. It is very possible that through the analysis, the researchers determine that rooftop rainwater harvesting is currently not a viable water supply alternative. This may be due to the high percentage of hotels with grass or thatch roofs which are not well suited to rooftop harvesting. Or alternatively, the costs of installing and maintaining gutters and rain tanks may be greater than the savings achieved through avoided water purchases over the lifetime of the rainwater collection system. An important part of climate change adaptation planning is to consider other ways of increasing water supply and different ways of reducing water demand. This might include installing small-scale desalination facilities or drilling bore wells to access groundwater. It could also include installing water-efficient appliances to reduce demand. A good analysis will consider many different options and determine the most appropriate strategy to improve water security in the project site. This might include installing water-efficient appliances in existing hotels, but requiring new hotels to have metal roofs and tanks capable of capturing and storing water. Each different adaptation option needs to be evaluated on the basis of how effective it is at providing water and reducing risk, how expensive it is, and whether it is consistent with long-term sustainability criteria. A detailed description of the method of how to identify and evaluate alternative water supply options will again be provided in a separate video to help you out.